We are now able to see back in time to almost 13.8 billion years ago, which gets us very close to the Big Bang, the event that created the universe. Our understanding of the end of the universe has expanded, and although science fiction and ancient writings frequently depict apocalyptic events, the reality may be even more bizarre. What if the beginning and end of the universe are the same? The scientific community has been completely shocked by recent discoveries made by the James Webb Space Telescope, which indicates that the cosmos may have stopped growing long ago. This finding supports a prediction made by renowned scientist Brian Cox, which offers us fresh insight into the ultimate destiny of the cosmos. We find evidence for what appears to be an even more significant event than the Big Bang itself by studying light that started its journey before galaxies existed. Might we be on the verge of another Big Bang? Come along as we examine James Webb's startling discovery that the cosmos might have stopped expanding and dive into this groundbreaking finding. Regarding the universe's beginnings, if there's one thing we know for sure, it's that the Big Bang is the center of our existence. The scientific community agrees that the Big Bang signaled the beginning of our universe, despite the existence of competing ideas such as everlasting inflation or an oscillating cosmos. Nevertheless, the intricacies of the Big Bang are frequently oversimplified, even if it is widely accepted throughout popular culture. The Big Bang was much more than an explosion, despite the fact that people who are not familiar with astrophysics may easily mistake it for such. During what is referred to as the inflationary epoch, it started as a singularity, an impossibly hot and dense point that quickly expanded. The cosmos expanded in an unfathomable way when it was just 10 to the power of -34 seconds old, in less time than it took for a golf ball to grow from subatomic size. After this explosive beginning, the cosmos cooled and protons, neutrons, and electrons formed, among other elementary particles. Eventually, the atoms and stuff that comprise everything we see today were formed by the combination of these particles. The universe's expansion was taken for granted for many years. For example, textbooks from the 1990s asserted with confidence that the universe was still expanding. The Hubble Space Telescope unmistakably demonstrated that the cosmos was expanding and that it was doing so more quickly. But new information from the James Webb Space Telescope has challenged this perception. The scientific community has been rocked by the unexpected discoveries, which imply that the cosmos may have stopped growing. This discovery has significant ramifications and calls into question our basic conception of cosmology. Is the world really no longer expanding, or have we always misinterpreted this phenomenon? What implications does the universe's cessation of expansion hold for its future? Though this is incorrect from a scientific standpoint, the creation of the universe is sometimes pictured as an explosion. NASA has made it clear that just as space didn't exist before the Big Bang, the universe didn't expand into it. Rather, the Big Bang signifies the universe's simultaneous birth of space. The universe was dark for the first 400 million years following the Big Bang. The cosmic dark ages came to an end with the formation of the first stars and galaxies, which illuminated the cosmos for the first time. On the other hand, our solar system did not develop until almost 9 billion years after the Big Bang. It is as exciting as it is horrifying to consider that the cosmos may not be growing. Up until recently, scientists thought that dark energy was the reason behind the universe's acceleration of expansion. On the other hand, current results from the James Webb Space Telescope raise the possibility that this expansion has stopped. This discovery might indicate that the cosmos is beginning to contract in reverse. A big crunch-like event of this kind might ultimately cause the cosmos to collapse catastrophically, returning everything to its singularity of origin. This unusual transition from an expanding cosmos to one that may be retracting begs many issues regarding the eventual fate of the universe. Although we have come a long way in comprehending the universe, our technological capabilities are still restricted. We still have to deal with incomplete data, even with sophisticated instruments like the Hubble and James Webb Space Telescopes. Cosmic microwave background, an echo of the Big Bang, is one of the discoveries that forms the basis of theories concerning the Big Bang and the expansion of the universe. But technical limitations prevent us from personally witnessing events like the Big Bang. The possibility that the universe is not expanding anymore is a sobering reminder of how much more research is ahead of us and how quickly new information can change our perception of the universe. Though unsettling, the notion that the universe has ceased to grow is not wholly unexpected. If there was sufficient energy in the universe, scientists have long conjectured that it might collapse again. The results of the James Webb Telescope point to a future in which the universe compresses rather than expands, suggesting that this scenario may be closer than we previously believed. One thing is certain: our knowledge of the cosmos is continually expanding, and the universe may yet have many surprises in store for us. This is true whether we are seeing the beginning of the end or are just discovering a new chapter in the universe's life cycle. The most renowned scientists at NASA thought they had solved the puzzle of the universe's expansion in the 1990s. Their hypothesis revolved around gravity as the ultimate force that governs the universe. However, what we currently know is very different from those initial concepts. At that time, astronomers projected that the expansion of the universe would eventually slow down and result in a massive cosmic collapse. However, what if the energy density was insufficient to stop this expansion? The scientific community was plagued by this horrifying possibility, but their theories were merely educated guesses because of the lack of available technological resources. But one thing they were certain of was that gravity will eventually stop the universe's expansion. It made perfect sense at the time. The universe, being a dense area of matter, would remain intact under gravity's pull. Galaxies would pull together, and the gravitational force would oppose the rising distance between cosmic bodies. Up until 1998, when the Hubble Space Telescope upended everything we believed to be true, this was the consensus among scientists. Hubble's task was straightforward: investigate far-off supernovae to track the expansion of the universe. However, what it showed was something that no one had anticipated. The cosmos was expanding faster rather than slower. The scientists were taken aback. This was not merely a small mistake. Rather, it was a revelation that required a radical revision of the basic assumptions of cosmology. It seemed that gravity, which was supposed to slow down the expansion, was helpless. The speed increase was perplexing. What force was causing the cosmos to expand more quickly if gravity wasn't the cause? At this point, the idea of dark energy, an unseen, enigmatic force that the universe is expanding faster than ever before and about which we still know very little, began to be discussed in scientific circles. Even while our knowledge of dark energy is still rudimentary, what we do know is sufficient to challenge our presumptions. The universe is made up of only 5% normal matter, which is what makes up galaxies, stars, planets, and humans. Dark energy and matter make up the remainder. Even Einstein's cosmological constant, which he previously thought to be his worst error, was confirmed by this revelation. It turns out that the explanation for why the cosmos is expanding faster than ever may lie in this constant, which characterizes an intrinsic force within empty space. In the era of the James Webb Space Telescope, JWST, scientists are facing yet another shocking discovery. There may be dark energy present in the cosmos, which would explain why it appears to have stopped expanding. According to the hypothesis, dark energy and gravity are engaged in a cosmic tug-of-war that will ultimately determine the fate of the universe. For a while, it appeared as though dark energy was triumphing, causing galaxies to expand apart at a never-before-seen pace. However, this growth has suddenly inexplicably stopped. What is happening? It's terrifying to consider that gravity could be able to overcome dark energy and halt the expansion of the cosmos. If accurate, it would imply that the universe is eventually approaching contraction, a big crunch-like situation in which everything falls back into a single point of singularity akin to the Big Bang. This suggests that a new cosmic era might be approaching if the idea is correct. According to the Big Crunch, after dark energy is vanquished, the universe's gravitational pull will become so powerful that it will halt expansion and suck everything, planets, galaxies, and stars, back into a dense singularity. According to certain theories, this would initiate Big Bang 2.0, resetting the cosmic clock of the universe. Should gravity ultimately prevail in this conflict, the collapse may occur sooner than anticipated. According to a Princeton research, there may not be much time left before this acceleration stops, shorter than there has been since the end of the dinosaurs. That's a mere blink of the cosmos eye. This begs the disquieting question: are we really nearing the end of the cosmos faster than we thought? For a long time, astronomers thought that the universe would experience a big freeze, in which galaxies would drift apart to such an extent that the energy distribution would become thin and darkness would last forever. But the Big Freeze is out of the question now that it has been determined that the universe's expansion has stopped. Alternatively, we could witness the Big Crunch, the collapse of the universe. The Big Crunch appears to be a far more terrifying, conceivable end for the universe. Whether the universe freezes, crunches, or does something quite different in the end, one of the greatest mysteries of our time is still how it will end. We might still discover the mysteries that determine the fate of our universe as we continue to investigate the cosmos with groundbreaking instruments like the James Webb Space Telescope. With this new knowledge at our fingertips, there are enormous ramifications in case of a big crunch. It is now the responsibility of scientists to investigate this intricate occurrence in an effort to solve any potential cosmic riddle. With its unmatched powers, the James Webb Space Telescope is set to completely transform our understanding of the dynamics of the cosmos. Through time travel, the light from far-off galaxies and supernovae can be observed, providing researchers with remarkable precision in their analysis of cosmic expansion and contraction patterns. A key question in this research is how dark energy and gravity interact. For many years, it was believed that gravity was the only force in the cosmos that could truly bring matter together. On the other hand, dark energy, which makes up an astounding 68% of the universe today, acts in opposition and accelerates the separation of galaxies. This cosmic tug-of-war paves the way for a more thorough investigation of the long-term interactions between these forces. There are interesting questions about the possibility of dark energy's decreasing influence. Will dark energy be defeated by gravity if it starts to make an assertive move? Could this cause the expansion to reverse, preparing the way for a time when the universe contracts? Scientists are investigating the ramifications for cosmic structures and life in our universe as they consider these possibilities. The James Webb Space Telescope is doing cutting-edge astronomical research, and its findings could yield vital information on the dark energy distribution and the rate at which the universe is expanding. Webb will contribute to our understanding of how the cosmos has changed over billions of years and how it might change still by examining light from the most distant galaxies. The universe's fast expansion may be slowing down, according to recent discoveries, which has sparked fresh theories on dark energy's destiny. Are we about to see a cosmic reset in which gravity takes control again? Such a change could drastically change how we perceive the timeline of the cosmos. Existential concerns regarding humanity's future are brought up by the possibility of a big crunch. Should the cosmos collapse, what would that entail for life as we know it on Earth? The possibilities seem terrifying. A pitch-black sky, the eventual vanishing of stars, and a return to a singularity in which matter is concentrated into a single, infinitely dense point. Even though these ideas can be uncomfortable, they also serve as a reminder of our interconnectedness with the universe. Knowing the fate of the universe can encourage us to live in the present. The immensity of time and space highlights the beauty and fragility of life and puts our existence into perspective. All stars, galaxies, and cosmic occurrences serve as a constant reminder of where we are in the universe and should value the time we have left. We are reminded as we go further into this new era of cosmic inquiry that every new finding adds another layer to our understanding of the riddles of dark energy, gravity, and the ultimate fate of the universe. Even if the mysteries of the cosmos may not be entirely solved in our lifetimes, we are getting closer to a thorough comprehension of it with every step we take. The quest for knowledge is an age-old activity that represents humankind's intrinsic curiosity and desire to understand the world we live in. Our trek across the stars will continue regardless of whether we encounter a big freeze, a big crunch, or an unexpected cosmic fate. It will be motivated by the unwavering search for knowledge and the dream that we might someday discover the mysteries of our universe. Please remember to like and subscribe to our channel if you like this educational movie and would like to see more fascinating videos about the secrets of the universe.